Hey there guys, welcome to my walkthrough of the 2018 OCR MEI New Specification A-Level Maths Paper 3, which is Pure Mathematics and Comprehension. So, each question is in its own video. You can get to the playlist from the description, and I'll pin it as the top comment. Also, in the description are the Paper 2 and Paper 1 walkthroughs, as well as the website to get the papers and my A-level content. Okay, if you're finding these useful, please give us a thumbs up, get subscribed, be awesome. Let's go. Okay, question 10, 10 marks, vectors and calculus. Good times. Okay, so point A has position vector A, B, 0, where A and B can vary. Point B has position vector 4, 2, 0, and C is 2, 4, 2. ABC is an isosceles triangle such that AC is equal to AB. Part 1 wants to show that A minus B add 1 is equal to 0. Okay, so classic maths, where does this equation come from? Think about what we can do with the info that we are given. So we know that AC is equal to AB. So that means the magnitude of A to C is equal to the magnitude of A to B. Remember, the magnitude of a vector is just its length. So, let's find A to B and A to C. So, A to C is C minus A. So that is 2, 4, 2 minus A, B, 0. So that's our vector A to C. Now let's also find A to B. So A to B is B minus A. So that is 4, 2, 0 minus A, B, 0. So 4 minus 8 2 minus B 0. Okay, so the magnitude of AC A to C is the square root of 2 minus 8 all squared, add 4 minus B all squared, add 4. So that's all square rooted. Now the magnitude of A to B is the square root of 4 minus A add 2 minus B all squared. So 4 minus 8 squared add 2 minus b squared. Now we know that AB is equal to AC, so that means that root two minus a squared and 4 minus b squared and 4 is equal to the square root of 4 minus a squared and 2 minus b squared. Okay, right, square both sides, so we get 2 minus a squared and 4 minus b squared, add 4 is equal to 4 minus a squared, add 2 minus b squared. Right, expand brackets. So, over here we are going to get a squared minus 4a add 4 add b squared minus 8 b add 16 add 4, so that's add 20. Then we got on the right a squared minus 8a add 16 add what's that square doing that? There we go. Add b squared minus 4b add 4. Right. Okay, so there's a lot of simplifying here. So we got an a squared and a b squared on both sides. So we can subtract these from both sides. Okay, let's see then what we're left with. So on the left, we've now got 4a, and then we got that plus 4, but we'll worry about that in a moment. Sorry, it's minus 4a. Right, we got minus 4a. We got minus 8b. Then we got 4 add 20. So that's add 24. Now on the right, we've got minus 8a. Add 16, we got minus 4b, and then we got the 16 and the 4. Which is 20. Okay, now let's get everything on the same side. So we're going to add 8a. So minus 4a, add 8a, it's 4a. Then we got minus 8b, and we're going to add 4b. So that's going to give us minus 4b. And then we got 24 minus 20, it's going to give us 4. And that is all equal to 0. Divide through by 4, a minus b, add 1 is equal to 0. Boom. Okay, then for part 2 and 6 marks, we want to determine the position vector of point A such that triangle ABC has a minimum area. Keyword minimum. That's screaming differentiation. So, I'm not going to try and draw this triangle in 3D. I can barely draw a circle, so it won't go very well. But even in 2D, we can get a game plan. So we know that, what are we told? We are told that AC is equal to AB. So, I'm just going to put A has to be at the top, and then B and C can be either one at the bottom. Now, remember that this triangle is not sat perpendicular to the base. So we don't want the perpendicular height. What we need is this point here, which we're going to call M. Now what we need to do is find the length A to M. So the reason being, area of a triangle is base times height divided by 2. Again, remember we're not thinking perpendicular height because this triangle is in 3D space. So essentially we need this length from the base of the triangle to the tip. So M is the midpoint of BC. Now we can find them. So M, it's going to have the mean coordinates of B and C. So M is going to be, so the x coordinate of B is 4, the x coordinate of C is 2, so 2 add 4 over 2. And the y coordinate is 2 add 4 over 2. And then the z coordinate is 0 add 2 over 2. Okay, so M has coordinates, or position vector if you like, 3, 3, 1. Cool. So we now know the point of M. 3, 3, 1. So we want to work out the magnitude of the vector A to M. So let's work out A to M. So A to M is M minus A, which is 3 minus A, 3 minus B, and 1 minus 0, which on a good day is 1. So the magnitude of A m, A2m, or the length am, is the square root of 3 minus a squared add 3 minus b squared add 1. So, the area then is, we don't have all the ingredients, so we need the magnitude of BC times the magnitude of AM all over 2 area of a triangle. So we need to find the magnitude of B to C. So that's going to be, how should we do it? Let's go over it. Okay, so magnitude B to C is, so B to C is C minus B. So we're going to be doing 2 minus 4 is minus 2. So it's going to be the square root minus 2 squared add 4 minus 2 squared add 0 add 2. So 2 squared again. So that is the square root of 4 add 4 add 4, which is 12. So the length BC is root 12. So now we can say the area of the triangle is root 12 times root this lovely thing, so 3 minus a squared add 3 minus b squared add 1 all over 2. Okay, now this is what we want to minimize. Okay, so we can simplify that a tiny bit. Root 12 is root 4 root 3, so it's 2 root 3. So we've got 2 root 3 over 2. So we can get rid of the 2 on the bottom. And then at the start, we're just going to have a root 3. Okay, now then, this is where the equation that we found in part 1 is going to come in handy. We now want to minimize this guy, so let's call it A. Now we're going to do that by differentiating, but at the moment it's in terms of 2 variables. We need it to be in terms of just 1 variable. So we know that this question is hard. We also know that a minus b add 1 is equal to 0. So I'm going to use that to get a on its own. No, I'm not. I'm gonna be on its own because it's less work. So we can get that A add 1 is equal to B. So we're going to substitute that into this. So the area is the square root of 3 minus A all squared add. Okay, so we got 3 minus B, so that's 3 minus A minus 1, so that's 2 minus A squared. And then we got the add 1 at the end. Okay, so we're happy now because we have an expression for the area in terms of one variable. Let's expand all those brackets and hope that this simplifies nicely. And also, let's not forget our root 3. Start. Okay, so the area is root 3 times the square root of A squared minus 6A add 9 and A squared minus 4A add 4 add 1. So that's root 3 times the square root of 2A squared. And we got minus 6A minus 4A, so that's minus 10A. Then we got minus, no we don't, we got add 9, add 4, add 1, so that's add 14. Okay, so I think that is as nice as we are going to get A to B. So, for a minimum, d A by d little a is equal to 0. So now we need to differentiate this. So let's rewrite this as that quadratic to the power of a half. So dA by d little a is root 3. Okay, so then, by the chain rule, the stuff inside of the brackets differentiates to 4a minus 10. Now the power comes down to that's half. Then we get 2a squared minus 10a and 14 to the minus 1 half. Okay, so that gives us root 3. Now that we got 4a minus 10 times a half, so that's 2a minus 5. And then that's multiplying the quadratic to the power of minus 1/2. So that means over root 2a squared minus 10a and 14. So that is our derivative times bracket on the end. Right, now then, if we set that equal to 0, so root 3 times 2a minus 5 all over root 2a squared of minus 10a add 14 set that equal to 0, we can make things look a lot nicer. So multiply through by the bottom, that disappears, divide through by the root 3, that disappears, 2a, add minus 5 is equal to 0, add 5, divide by 2, a is 5 over 2 result. Okay, so now that we know what a is, it's a simple game compared to what we've just done. I will point out that sometimes with differentiation problems like this, we need to prove that this would lead to a minimum. You would do that by finding the second derivative. I've checked the mark scheme and they don't need us to do that for this question, which is good, because by now we really have earned most of these 6 marks, both to differentiate anymore, so we don't need to. Cool. So we know that a minus b add 1 is equal to 0, 5 halves is 2.5, 2.5 add 1 is equal to b, so b is 3.5, so a has position vector 2.5, 3.5 and 0. Thought it was. Best to check. So, there is the question done. Boom.